Wallenda will most likely have to deal with sustained winds. And with more than 4,000 square inches of combined surface area between him and his 40-pound balance pole, the steady wind could treat him like a human weather vane. But potentially more troublesome are shorter, sudden gusts. As waves of air are squeezed through Chicago's high-rises, they can accelerate. The effect is similar to a bicycle pump, in which the air leaves the nozzle roughly 6 times faster than the pump is compressed. In November, gusts in Chicago have been measured at up to 70 miles per hour, nearly the wind speed of a Category 1 hurricane. Moisture could also be a factor. If the temperature falls to near the dew point, drops of water may form. In wet conditions, the coefficient of friction, or traction, between the wire and Wallenda's elkskin moccasins could decrease by more than 30%. Not ideal when he's walking up an incline that's as steep as San Francisco's iconic Lombard Street. Chi-Town's average temperature in early evening at this time of the year is 48 degrees. If there are sustained winds, for example of 15 miles per hour, the wind chill could drop to a numbing 42 degrees. This could be especially problematic during Wallenda's blindfolded second crossing. Without visual input, his balance depends in part on what's called proprioception. This is the brain's ability to track its body positions using sensory neurons in the inner ear and receptors in the muscles and ligaments. But when exposed to cold, these sensors can become less responsive. If his walk is in close to freezing temperatures, it could reduce his ability to judge shifting winds through receptors on areas of exposed skin, such as his face. This prolonged exposure to cold might also diminish his ability to make quick adjustments, as his reaction times could be 20% slower.